So here we're going to look at a question where we're going to be doing just a little bit of calculus. We have a total amount of charge that has entered a wire at time t given by an expression, which is Q, our charge, is equal to 4t minus t squared. So the amount of charge here is dependent on the time, so it's varying in time. And we're told that t is positive and in seconds. So the first thing that it asks for is to find an expression, that is an equation, for the current in the wire at some time t. So what we have is an expression for the total charge. What we want is the current. And so our current, I, is equal to the change in the charge in the change in time. It's a rate of change. That is to say that it's dq dt. And so what we're going to do here is just take the time derivative of our expression for q. And that would be, substitute that in there, 4t minus t squared. And so then we take the derivative, so d dt of 4t is 4 minus d dt of t squared is 2t. And that's it. There's our expression for the current in the wire at any time t. So then it asks, well, can you graph that to get a sense of what this might look like? Sure, we can do that. Just hold on a moment. I will draw up some axes. So we'll have I on this axis, and we will have time on this axis. And I guess we should note some points along here. Okay, so this will be about 1, 2, 3, 4, and we'll make this maybe 2, 4, -2, -4. Getting a sense just out of the equation of what the values might turn out to be. Okay, so when looking at an equation and wanting to figure out generally what's going on, it makes a lot of sense to look at the intersect points. So, if we're going to look at this and say, well, where t is equal to 0, then what's I? If t is equal to 0, then I is 4. And we could say, well, where I is equal to 0, what's t? Well, if I is equal to 0, then we can bring the -2t over to the other side. We get 2t is equal to 4. And so that happens when t is equal to 2. So this is our little 2 important points. So we can say, okay, well, here's point 1, and then here's point 2, and so there we can draw a line. And we actually know, just looking at the equation, that this is going to be a straight line. It's going to be a linear line. So it only asks us, I think, between 0 and 4. So we'll try to limit it between 0 and 4. And there we go. So that's between 0 and 4, what we have for the current. And you see that the current starts strong. It's at 4, and then it decreases linearly until we end up having a negative current. So it's flowing in the other direction. And that's it. So just a simple derivative, really getting at this conceptual understanding of the relationship between charge and current. And that's it.